Good afternoon, everybody. And this is the 20th lecture of series of lectures by eminent scientists. And we have very eminent scientist, Professor Sushil Kumar Das, from he is retired from CAS IIT New Delhi, and uh, uh, he is very well known to this meteorological community. Many of our officers are his students, and he is very much regularly guiding us uh, on various meteorological related activities. Before, at the very outset, I would request our DGM to kindly welcome Professor Dash with the flower of bouquet. Total. So, before proceeding further, I would request our DGM to kindly say a few words.
Namaskar, good afternoon to all of you. Respected Professor S.K. Das, former faculty of IIT Delhi, and a well-known figure with respect to the climate studies. Distinguished delegates and participants in this popular lecture being delivered by Professor Das. Dear students, ladies and gentlemen, on behalf of India Meteorological Department, I extend a warm welcome to Professor S.K. Das to this August gathering, which is being organized online and offline by India Meteorological Department to commemorate 150 years of establishment of India Meteorological Department. As all of us know, that the success of any weather service depends on various components. Among them are the improvement in meteorological observations, the numerical modeling, communication system, decision support system, forecasting, and early warning, and sectoral applications. So while considering all these components, you will find that there is another important pillar which contributes to the enhancement of the knowledge, which contributes to the conversion of science to the services, and that is the research. So Professor Das is famous globally towards the climate research, and his contribution, his pioneering research has enhanced the knowledge of Indian meteorologists, but also the knowledge of global scientists. His pioneering work, if you just look at, you will be happy to know that it included the monsoon, the climate modeling, the extreme events like heat, etc. He is also known for his pioneering research and seminal contribution towards the climate change. His contribution towards the climate change has resulted not only in understanding and prediction, but also it helps in adaptations and mitigation measures. We are really happy, sir, you are present here, spoiling or even sharing your time to be with us and share your views, knowledge, experience, and expertise. And I am sure your lecture will be touching each and every one of us, those who are involved directly in the field, but also it will help the people who are indirectly associated with this field. There is no one perhaps left out in this world who is not affected by weather and climate. So therefore, every one of us gets benefited with the development of knowledge and sharing of the knowledge. Another most important contribution of Professor Das is the capacity building. As Dr. Soni was telling, many of us has been benefited with his teaching. He has been a profound teacher. He has enabled the knowledge creation and knowledge resources management in the country. As all of us know that when the point of research came to mind in the early days in 1960s, then it was thought that there should be some research establishment in the country, and India Meteorological Department handheld at that time with IIT Delhi to establish Center for Atmospheric Sciences. And mostly you can say from the very beginning or little earlier, few years after, Professor S.K. Das has been the part of Center for Atmospheric Sciences, IIT Delhi. In that capacity, he has always been supportive. He has always helped to improve the capacity of the scientists, not only in IMD, but also the entire meteorological fraternity in this part of the country. He has produced many PhDs, many MTech students through development of the thesis, PhD thesis, and MTech thesis, etc. So we are all really indebted to you, sir, for your contribution to the science of meteorology and its application to the society. And I am sure for the years to come, you will also continue like in the past for development of the capacity, for conversion of science to society, and also improving the knowledge through research and development of technology. So with these words, I once again welcome Professor S.K. Das to deliver a special talk on actionable climate information and modeling of climate. Thank you very much. You can speak here also.
Yeah.
No problem.
So, you made already DGM sir has introduced Professor Das, but I would request Anup to formally introduce for benefit of our young audience.
Thank you very much, sir. Namaskar and very good afternoon, sir. I'm Dr. Anup Misra from IMD New Delhi, and I'm very delighted to get an opportunity to introduce our speaker with the audience today. It's an honor to have Professor Das sir with us. Sir received his PhD from PRL Ahmedabad and for his work on stability analysis of Indian monsoon. And Professor Das superannuated from IIT Delhi as a professor and head of Center for Atmospheric Science, and continued there as emeritus professor for the next 5 years till August 2018. Subsequently, he was associated with DST Center of Excellence in Climate Modeling as visiting scientist. His research interests are interannual variability of Indian summer monsoon, climate modeling and climate change studies, high performance computing in environmental sciences. In his 52 years of experience, Professor Das has successfully supervised several PhD, MTech, MPhil, MSc, MCA students. He published more than 140 peer-reviewed papers, wrote one book and edited 3 books related to climate change in India. And Professor Das is a fellow of Royal Meteorological Society and IMS, recipient of prestigious Dr. A.D. Varnikar Award of IMS, senior associate of Abdus Salam ICTP for a period of 14 years, and life member and member of a number of national and international bodies such as AMS and National Academy of Sciences in India. He served IMS as its president for 2 years during 2018 to 20, and currently he represents region 2 countries of WMO in the Council of IFMS and chairs its Committee on Education and Training. And Professor Das is the founder president of Foundation for Education and Research in Climate Change, FERCC. Kindly join me in welcoming Professor Das.
Thank you, Anup. So now we request Professor Das to please. Yes, sir.
Good afternoon, everybody. First of all, I would like to congratulate IMD at 150, and going strong. And I am sure that the way they are proceeding, the future of our country is very good in the field of weather forecasting, and also to some extent climate change. And people will start believing more and more of the forecast at all time scales, whether nowcasting or 2-3 days, short range, medium range, or to the extent of climate service also, because they have active in air pollution, they have activities on all these sectors of climate change. I would like to thank Dr. Mahapatra for inviting me. It's an honor to speak on this 150 years of celebration of IMD. And I'm very happy that I am amongst you here, and also so many our colleagues and students have joined, as I can see on the net virtual. I thank also Dr. Mahapatra and Dr. Soni and Dr. Mishra for speaking nice words about me. I have decided to, because I had a choice, I had decided to speak on this actionable climate information and modeling the Earth system. Because climate information is the in thing today. The second part, that the modeling of the Earth system, that is actually based on my last affiliation. That is the professor and head CAS, where in CAS I stayed for more than 30 years, and that is concerning my research and modeling. But the other three, where I have written about the foundation and IFMS and IMS, those experiences have persuaded me to speak about this actionable climate information, because I thought that this tool, mixing of these two will be very interesting, especially for the students, early career scientists, who are, because now the scope of working on weather and climate is very, very large. And there are many fields which some of us don't know. And wherever possible, I have cited from which source I have taken this, and I acknowledge that here. Next, please. You see, this is about the scope of the climate change. On the left-hand side, you can say that is called via. Some people put vulnerability first, but here it is impact, adaptation, and vulnerability. On the right-hand side is the climate models. And at the top, you can see integrated assessment models. These are all superimposed on each other. So all these three are important so far as the climate information is concerned. You can see on the left-hand side that impact, adaptation, and vulnerability, they are mostly, the important aspects are sea level rise, cryosphere, there is melting of the snow, human settlement, infrastructure, all these things. On the right-hand side, again, the important aspects of climate model, that is atmospheric processes, ocean, cryosphere, and superimposed on that integrated assessment model. That means you can say application models. Almost every field you can think of. That is why climate is, science is now talked even on newspapers. And few years back, scientists even were not believing there is a climate change. Today, the climate change, that is so-called rise in temperature, has affected also weather. Climate change has affected weather, which is very, very interesting and also very, very important from the societal point of view. So you see human health, you see agriculture and forestry, you see human settlement, you see this terrestrial ecosystem, all these aspects of our life, which touches our life, are there. So that is why you need integrated assessment model. So modeling of the climate system is very important in addition to the observation aspects and other aspects we'll discuss gradually one by one. Next, please. Here, climate change means it's a popular talk, but I know that popular talks have different types. Different types. Here I believe that the audience here is those who have knowledge about weather and climate. So I have tailored my talks, the slides, the similar way. So climate change is most important in mitigation because greenhouse gas is the culprit, and also we know that it is a global problem, although actions are at the local level. And greenhouse gas emission is linked to the industrial evolution. It has happened because of the fossil fuel burning, industries, transport, so many other things, which are man-made. And industry is connected to the so-called growth. I have written so-called growth because I am going to talk about the sustainability, sustainable growth. Then economy of a country is the backbone of the growth, so you need industry. So now we can understand that why the reduction, although the simple solution is reduce the greenhouse gas, which will not allow the temperature to rise, why it is not so simple? Because it is connected to the geopolitics and economics. It is connected to the essence of our growth. Because after industrial revolution, we understand the growth means we should use energy and be comfortable and increase our materialistic needs, etc. That is the growth. Next, please. Now, this is what same thing, but authentically, Jennifer Morgan, Executive Director of Greenhouse International, who was formerly in the World Resource Institute, he has told the same thing in a very emphatic way, that climate change is mostly due to the burning of fossil fuels, which currently supplies most of modern society's energy system, and hence the solutions are economically, politically, and socially complex. This complexity has made international climate negotiation moving slow. Actually, there are so many agreements on climate change for last several years. I'll talk about that, but it's very slow compared to other fields because the matter is very complex. And it is required to have some fresh thinking in this type of agreement, international agreements. Otherwise, it will continue to be slow and the whole process will be delayed. Next, please. Climate change issues, another point is the disparity. When you compare about the climate change in the developed countries like US, Europe, or to talk about India, that is the developing part or whatever you say, we are already developed, some countries think, but we are still thinking that we have a lot of things to achieve. So when you talk of the US developed country, then there are temperature rise, there is flood, there is forest fire, there is snow melting, all these environmental problems. But in addition to that, there are societal problems are management of climate change risks, including adaptation to a low carbon economy. The emphasis is to go to the low carbon economy, human capital management, particularly racial and gender diversity, and inclusion in the workplace. These are the important things. And questions around corporate purpose and how companies are serving the interest of all the stakeholders. Companies are concerned about the stakeholders. That is their emphasis. On the other hand, next please. For India, those environmental problems are there. But we have other serious problems like societal matters like poverty, unemployment, human health, education. Climate change impacts are felt in societal disparities in the above dimensions of the human life. So that is very interesting thing and important thing to focus on. It is not only rise in carbon dioxide or methane in the atmosphere, rise in temperature. There are other aspects because now climate change is also affecting the weather at a different time scale. Poor and the less privileged are not resilient enough to absorb this shock, that is the impacts of climate change in different fields. We'll discuss those. Next, please. So this is one I have borrowed from chapter 13 of the mitigation of climate change, contribution of working group 3 to air IPCC, that is the Intergovernmental Panel on Climate Change. You can see that there are 3 rings here, and the inner one, you can say international, then around that, the other ring is state level, country level, you can say, and outside is also sub-regional and country level. So in these rounded figures over oval-shaped things. There are different types of agreements, which you can see some of those oval-shaped structures are touching all the three. That means those are important at the international, sub-regional, and country level also. Some are in the international level, some are in the sub-regional, some are in the country level. This type of negotiations have been going on for several years. So there's so many agreements. Next, please. I've just given a glimpse of that. Next, please. I don't want to go into details of that. This IPCC, the sixth assessment report says that this is very emphatically they are saying that we are responsible. Recent changes in climate change are widespread, rapid, and intensifying. This is based on 234 authors and so many 66 countries like that. The sixth version of the IPCC investigation of the climate changes. And they are very categorical that human beings are responsible. And it is not yet irresponsible, irreversible. Some climate systems are irreversible, at least for centuries, but not all. There is some hope. So we have to think of those sectors where there is hope. And the aim is 1.5 degrees centigrade, not 2 degrees. Earlier, they were thinking that 2 degrees will be okay, rise will allow. But today, the limit is put 1.5 degrees. That is the end of the 21st century. That is the objective. Next, please. And if you think of these events were happening, weather events which are happening, same report says that extreme heat is going to be more frequent and intense, and droughts are increasing in some regions, which we see. So we don't have to really contradict these results. Heavy rain, more frequent and intense in most of the part of the country. We see in our cities and other cities also in our other countries. Wildfires will be more frequent, which is exactly happening. Not so much in our country, but think of Brazil, Australia, US. They're in serious problem because of the wildfire. Oceans are the most important aspect of the climate system. They are not only warming, but they are acidifying and losing oxygen. So the ecosystem in the ocean is going to change a lot because of the lack of oxygen and acidification. Next, please. So these are the different important aspects of the climate risk. I told that whether climate change is not only the rise in temperature or melting of the snow and sea level rise, is also affecting the weather, which is very close to all of us. Droughts, sea level rise, infectious disease, that human health, wildfires, and cyclones. This slide shows the statistics. That means in next few years, how many times the drought will has already occurred and will occur, how the GDP will be affected because of the sea level rise, how the infection disease by 2050 will encroach almost a lot of human beings, mosquito bites, malaria because of that, and about 500 million people will be affected because of this human health, which is a very, very important thing. And in Delhi also we feel now about this air pollution, which could be because of the climate change also to some extent. Not, you cannot say the temperature rise only, but other aspects of the climate change. And so many people are being affected by the heart disease and other lungs, etc. Wildfires, it says by 2030, the season could be 3 months longer. Wildfire season will be 3 months longer. That is what they have, the source is given there. That is his study and assessment. Cyclones, robust increase of the most devastating storms with climate change is evident under 2.5 degrees global. If you allow this to 2.5, we're not thinking, you cannot imagine about 2.5, but he thought that if we are thinking of 2.5, it will be devastated. And already we see that with the present rise of 1.1 or something like that global temperature, we are in a very precarious condition of the intensification of the cyclones, which is being very nicely predicted by IMD and appreciated all over the world. Next, please. And also it saves the early warnings. Because of the early warning, it has saved a lot of life since Odisha cyclone of 1999. This is statistics given by some scientists from 1970 to 2019, number of different types of reported disasters. Because climate change means immediately you think now the disasters which are occurring. I mentioned about those disasters. There is most talked about. Here it will give statistics about the disasters, deaths, and the economic loss. First figure show the disasters, second one show the deaths, and the third one show the economic loss. Disaster means number of disasters. Again, on the right-hand side, this column show your decadal wise, and left-hand side is giving a summary of percentage of increase or something like that. How many percentage of people were affected? So floods accounts to 40% of the disasters, followed by storms. The first one says, and the decadal disasters increasing number except the last decade. My presumption is that I could not only get the explanation from that, but my presumption is that the disasters are actually revised and counted at the end of the decade and end of the year. So there is some lag. Probably that will increase if you write report now, because you have to collect from all over the world. That's my presumption. No explanation is given. But you can see that overall it is increasing. Next is coming the deaths. Number of deaths, again, at the left-hand side you can see. There are storms leading to 38% of the deaths. It is followed by droughts. So top there was floods, then there were storms, and now storms and drought. Third one, that is deaths. So number of disasters increasing, deaths are increasing because of almost same reason. And economic loss. Economic loss on the left-hand side you can see the storms caused 54% of the economic loss, and it is followed by the floods. Again, flood is giving number of disasters are increasing, the deaths are also increasing and affecting more people, and economic loss is also because of the, and followed by, so economic loss because of the storms is the maximum. So overall you can say that the main disasters for us, for all over the world, is floods, storms and droughts to some extent, but mostly floods and storms. Next please. And these are, the studies have shown that these frequency have occurred or intensity have occurred because of the climate change, that the rise in temperature and greenhouse gases. Another statistics is very interesting figures, so I thought that I'll share with you. Disaster impacts by United Nations and World Bank country classifications. How many disasters have affected the economic loss, deaths, like that? Here I want to mention that typically UN has 3 types of classification of the economic classification of the people, economic condition. World Bank has 4 types. I don't know why. I cannot explain that. So left-hand side show the death and economic loss. Right-hand side also say death and economic loss. But classification is different, but you will arrive at almost similar results if you look at the figures. From 1970 to 2019 is the statistics. Weather, climate, and water hazards related to water accounted to 50% of all disasters, 45% of all reported deaths, and 74% of the reported economic loss, the lower one. 74% of the economic loss. So although there are 4 types on the right-hand side, you can think of the same, like developed people, less developed people, economically developed people, things like that. And this is the WMR class. So deaths are more in developing countries. Very interesting part. That is why I showed the disparity in the developed and developing countries over the climate change. Deaths are more in developing countries and the lower and middle income countries. developing countries, the economy is robust. So deaths are more in the reverse one. Deaths are more in the developing countries and lower and middle economic countries like us, Bangladesh. There are so many others in the global south. They call the global south. There are so many countries. Deaths are more. On the other hand, economic loss are more in the developed, that is economically robust countries and high income countries. So this is it is clear. Why? Because the people in these poor people are vulnerable to the climate change, so they are dying at a large scale. In developed countries, the economic loss, the infrastructure loss is more, but the deaths are less because they are able to save them and they are in a better condition. They have robust finance, so their infrastructure is affected. That is why economic loss is more, but death is less. Next, please. So death is more important. Actually, we will assume that human loss is more important than economic loss. Who is creating the economy? Human beings are creating. This is a particular slide about India. Again, WMO report. WMO State of the Climate Change Atlas. I have borrowed from that. That was the presentation, the Conference of Parties 26 that was held in Glasgow. Estimated by the United Nations Economic and Social Committee, that is ESCAP. And you can see the second line, that is India. How many billions? About 47, I think, something like that is written. I can see from here, but you can see that second. So second one is India having the, okay?
87, sir.
87%, billion, 87 billion. And they mentioned also that Amphan is the most disaster storm so far. Next, please. Am I correct? Amphan is the, or something has come later on.
No, fine.
Amphan.
Last super cyclone.
Last super cyclone. Then we have to understand this in the climate change sense, that understand the disaster risk, adaptation, and development. So this right-hand figure is also very interesting. You have to think about in the left-hand side arrow, you can see climate. Right-hand you see the development. And in the middle oval shaped, there are, this is the disaster risk in the middle. So there is vulnerability, there is climate vulnerability and natural vulnerability there, but anthropogenic change climate is also there. So risk comes because of these three factors. So when you take the development, what is said, the figure is said that disaster is connected to the, when you have development, when you have development, the disasters give rise to the proper disaster risk management. You do the proper risk management through your development, then climate change adaptation becomes better. In that case, the greenhouse gas emission will be less. So if the condition in another word you can say, if the poor people are helped, they are in a better condition, they don't adapt to other means which give to more greenhouse gas emission, like supplying the gas cylinder, etc. A small example I am giving. In that case, the greenhouse gas emission will be less. So the greenhouse gas emission will be less, and this loop will, so anthropogenic change will be less to some extent, and it will help the whole process. So disasters are because of three reasons, but if you take the proper development steps, it says that if you take the proper development steps, you change the condition of the societal conditions, then you can curb the greenhouse emission to some extent. I don't know what extent, the study will come in future, but it definitely helps to reduce the greenhouse emission. So you cannot isolate the climate change from the disaster risk management. So it has to be, in countries like us, we have to think about both, not only rising temperature. And we cannot stop the industry quickly. So suddenly you cannot reduce the coal, you cannot stop using the coal. That's why we decided that we will go phase-wise removal of the coal. You cannot suddenly, because we need poor people to be developed. So if you concentrate on the development, then the greenhouse gas emission will be less. Next, please. That is why this is, I will skip because there is not much time. This is about the Sunday framework, that early warning, they have given importance of the early warning system. That is again to risk management. I told you about the Orissa cyclone 1999. So many people were affected and 10,000 people died. But after that, because the organizations like IMD, state government, NGOs, and disaster central system for the disaster risk management, they jointly work. The early warning could be given, let us say 4 or 5 days before, because you need more time to evacuate the people and take proper action. If you give from 1 day the warning, if you give, it may not be so effective. If you give the warning before 3 days, 4 days, which you are doing now, then the people will, the government will take proper action because they have the time. That is very important. Early warning should be given more earlier. So scientists have the job of examining the cases and modeling development so that the early warning can be given as much before as possible. Then the other, because it's a joint activity. Next, please. Next, please. So this is now I am coming to the sustainable development goals. So that greenhouse emission is one point. Here also there is a part, there are 17 goals. Climate change is also one of the parts. But there are other parts also, human health, environment, so many, 17 topics are there. And this is the agenda for 2030. I don't know how far it will be possible to achieve this. It was adopted by the United Nations members in 2015. These 17 now, most talked about these 17 goals all across the world, including in India. Next, please. So same thing I am talking in a different way, that sustainable development goals, they have recognized the human activities, particularly the burning of the fossil fuel, deforestation, and industrial processes. They know that they are led to an alarming increase in greenhouse gases. Those who develop these sustainable goals, the different countries together, as we know, they also discussed about this. And we have, after that, we have found that really not much work has been done at the top level. Top level means the international level. It is true that local level, some observations show that at local level and some national level, like in India, some actions have been taken. Corporate sectors also. Most interesting that ESG, that is the environmental, social, and governance scheme and CSR schemes of the corporate sectors, which are formulated by the government policy, they are doing a lot of work in this direction, sustainable goals, water conservation, planting the trees, taking health of the human, those who are affected, energy reduction, depending on the renewable energy. In India, so many countries, and they find it is beneficial also, because more and more sectors are going for the compliance of the ESG. Because once they have that certificate, carbon trading also possible. Once they have the certificate, the rating in the market is going up. People are buying, we are thinking to buy AC or heater which consume less energy, less electricity like that. So rating of they are not losing anything. You don't have to really please only the stakeholders and want to take profit. Here you can do both. So you have to develop the technology, which will come gradually. And another interesting where I am involved, in all these things I am involved to some extent, Indian Bureau of Statistics, you will be happy to know that they have integrating the sustainability goals into their, because they are the institute of the our country, where they maintain the standards of different industries, manufacturing industries. What type of instruments should be made for electrification, electronics, electricals, etc. so that the consumption will be less and they can curb the greenhouse gas emissions and sustainability will be maintained. But at the international level, I have told that there are issues for universal ratification and agreements. Still, we are trying to have agreements. Although we are signing certain things, these countries, very difficult to bring to the table and implement. Next, please. So I think I should switch over to the modeling part. I know that there is a packed program. Next, I have already explained about the sustainable development and climate change earlier. So we can go to the next slide, please. Yeah. So now the action is the most important thing. I will give examples of 3 or 4. Like 23rd March 2014, we have the WMO Day. That was the action, emphasis on the action. Next slide. You go to Environment Day. It came 5th June 2024. Again, action, climate action, emphasis on climate action. Next, please. These are the important international days. Then Ozone Day, here 16 September. Here also the climate action, that how to advance the climate action. Everywhere, even I heard that 2-3 days back there was World Energy Day, and that's also action, sustainable growth. In the Energy Day also they are talking of this. So every organization, internationally or international, they are all focusing on the climate action, which is the in thing. And as climate scientists, we should be aware about that. And students should think in that line also, how to connect these modeling results. Next, please. So this is the UNFCCC COP28. I think here the important point is the climate finance. I wanted to talk about there are 4 important actions. That is energy, as you know, climate finance, which is upcoming branch for the young students, because this finance has to come from the developed countries to the developed country for technology transfer. And also any action you take, you need finance. So how the finance will be created for the climate action, how it will be shared, all these things are important. And also it focuses on lives and people, that sustainable goals. And last one is sustainable. Next, please. And India, I'm just giving a glimpse of India government's action. Most important thing is about the 2008, they started this Prime Minister's office. And there are 8 missions like solar mission, then enhanced energy efficiency, sustainable habitat, water mission, mission for sustaining the Himalayan ecosystem, mission for Green India, mission for sustainable agriculture, mission on strategic knowledge for climate change. Now 2 more added, National Mission on Climate Change and Human Health, and National Mission on Coastal Vulnerability. Here also you can see that these are all action oriented and emphasis on the sustainable development. Next, please. This is a good news for India. I've got it from Times of India. Somebody has examined and found that India is much ahead of the race, better than US and UK, so far as the climate race is concerned. That means our actions are more prominent than we're ahead. That the study this says. Somebody, Banerjee, some Chandra Mata Banerjee, something like that. Next, please. And this is about I think I will also switch this. I look at my wristwatch and find that less time. Okay, next, please. Now come to the second part of my talk, climate modeling, which many students and scientists know about this. This is the nice picture about the global modeling system, which consists on the left-hand side space, atmosphere, land, vegetation, ocean, ice, snow, all these things on the left-hand side. And the processes are physical processes, chemical processes, biological processes. These are the most important. Biogeochemistry also there. And if you look at the modeling side only, before 1980, these are all descriptive models. Then came the mathematical development of mathematical models of the atmosphere, maybe two level, 3 level like that. Then developed of the coupled atmosphere. First came the atmosphere model alone. Then came the coupled model, or ocean is coupled to the atmosphere because without ocean, atmosphere has no meaning alone for climate study. Then nowadays the Earth system models. Okay, next please. And this is a very interesting read. When people have, students have time, they can go through this. That is 100 years of progress in forecasting and NWP applications. This is a report given by AMS, I think, some scientists from American Meteorological Society. That is what I remember. Very interesting read, actually. Next, please. I here this divided this whole modeling system into 4 eras. Then comes the next 50. You will also describe about the next 50. But here basically 1999 to 2018, here divided into 4 distinguished eras. First is the age of maps and geographical methods using graphical methods using advection, that many old meteorologists will remember how they were forecasting. That was 1990 up to 39. 39 to 56, aviation. The importance was given was aviation observations. 1956 to 85, mixture of the maps, graphics, and NWP. NWP started during that period, towards the end, not 56, little 60s like that. 85 to 2018 is the modern era. Then he has also given what will happen next year, next 50 years. Next, please. Next 50 years. This is very small, actually, where I am sitting to read all this. But I will say that he has divided these eras into 8 different categories. What type of physics were, this is 4 in this slide. What type of physics were used? What type of modeling developments were made? What type of organizations were involved in giving forecasting? On the third line, you can see that NWP started, satellite started during the same time, that is 85. Satellite and NWP, most of the developments, before that there was not. And then came the involvement of the private organizations. Then next please. And the last one is the Earth system model. Next please. And these are the 4 other which say that what will be the future. NWP in the next 50 years, you have to depend on cell phones and radar, drones, etc. for observation and forecasting, all this type of very high-tech things. Next, please. Which I will summarize here, 2-3 slides to gain time. Present status of NWP is close ties between research and development efforts. How it has happened so far, the progress, because there is a very, very close tie between the research organization and the development efforts. Many institutions work together, many scientists work together, many operational agencies work. Dr. Mahapatra mentioned about CAS, Center for Atmospheric Science, starting. It was because IMD funded and initiated that in IIT Delhi for research. So this type of close collaboration between different organizations. Now private sectors are also there. That is one of the most important reasons. I will put it as number 1. Then observational network, definitely observational network. Because of the large density, you get the ground truth. That also helps in getting the data for the model to give the input, and also to some extent understanding the physical processes. And archiving that data gives chance to the scientists to observe the progress, how the climate is progressing from those, examining those data. Then obviously theoretical advances in predictability, fluid dynamics, and numerical methods. Without numerical methods, it would have been very, very difficult, because how do you give the future? Important thing is the how do, of course, nowadays AI is improved, is used, will be used in future also. But without numerical methods, it will be very difficult to project the future. Then subgrid scale physical parameter scripts, how a cloud is put into the model, cloud physics, how the mountains are incorporated into the model. These are very important schemes which are developed by the scientists and helped in the today's forecast, either climate prediction or weather forecast. Then assimilation. assimilation of diverse observations from the ground, nowadays more from the space. These are very important things, and without that additional data, the model cannot really improve more, because that's called put garbage in and garbage out. That is not happening because you have more ground truth. What is happening today, you have more information about that, so you can extrapolate that in the numerical of the forecast so that it will give a better result in the future. If you have data at coarse resolution, you will not get that type of clarity for the forecast at the high resolution, 50 kilometer or so. Then nobody can deny that computing development and weather forecasting development are going together. From the beginning, in the Princeton University, GFDL, etc., they are all together. Developments in the high performance computing system, supercomputer, and their use for the prediction and climate studies. Next, please. More fast. And I would like to mention here, in addition to global model, our system models, what is important is this high resolution data, which is the COREX one, that is the VIA studies I told, vulnerability, impact, and adaptation. This program was meant for the land areas where people are really living, so that the regional models will be run across those areas. So you get the data at 50 kilometers, that was the objective then, for application studies, water, food, energy, ecosystem. So this was the objective of this system. So clubbing of the regional models into the global models have also tremendously helped. Next, please. In generating climate information. Next, please. And today, 14 geographical coverage areas there. Next, please. Earlier there was less. And this is, then I will mention about 2-3 sources of data which the young people can try. This is one is the C3S, that is called the Copernicus Climate Change Service. C3S, climate data store is available. This is again generated from the colleagues. They say that, I have not used that, but you have to test that. They say that it's globally available, and 0.25 and 2.25 kilometer resolution, and 5 surface daily variables at monthly resolution: air temperature, mean maximum temperature, precipitation, and mean near surface. What I heard from some students that this is quite useful and they are using. You can also look for the correct data from the IITM website. They have a devoted place for this, and many students in India are also using that. Next, please. And this is a very promising project, that is our system model 2025. I don't know whether really they will give in 2025 because it is next year. This is a European research project funding. I will just summarize by saying that it is our system model, but here the movement of the carbon is through the earth system is incorporated. I don't know exactly how. The carbon is the most important culprit. So they have, I think carbon cycle they have put into somehow. The explicit models are movement of the carbon through the earth system. So it will have a directly used. This application will be directly used. And this is coordinated by Meteo France. And the results from coordinated simulations with the new models will provide more robust guidelines on future global information, risk, etc. Here I would like to mention why this has importance and collects also. The most important, the most, you can say, highlight the most important weakness of the implementation of the Sustainable Development Goals, the lacuna you can say, is that we have a lot of data, but this data, most of those data have no meaning, they are inaccurate, and it cannot be used directly for the action. So here we have to think of what type of actions we should take, how the models will be developed. In that direction, this is a very interesting project. If the results come out, so students will get a chance to examine those. These are meant, like colleagues, these are meant to take action in agriculture, human health, because in agriculture there are crop models. In human health there are also models which like malaria and etc. But they need data, and those data, future data, I mean, those future data should be accurate. So sustainable development goals implementation need more accurate and high resolution data. That is lacking. So it's difficult to take action. Here there is a very important role of the model scientist. Even if whatever model output is coming out, you have to churn the what you call useful data from that. Most of the data may be useless, but you have to find out which are the meaningful data. Next, please. It will be clear from next 2 or 3 slides, especially ECMWF when I come to. Future roadmap in NWP, this is given by Thorpe and Rogers in 2018 publication. The data assimilation and observation, those are the most important things. You should get more data and assimilate more satellite data into the modeling system. Data assimilation has to be robust with more information. Predictability and dynamical, physical, chemical processes. Some of those are already there, but I think chemical processes are lacking. Some of the physical processes have also model errors. Those errors, I believe that can be rectified to some extent in parameter schemes, etc., by applying artificial intelligence and developing in different ways. Interaction among different components of the Earth system. So if you put all these things together, then you will land up in one thing that is called the application of numerical, environmental, and weather prediction. That is the global weather enterprise. There is something called global weather enterprise where private sectors are involved and government sectors are also involved, and ultimately all should work together for the environmental and weather prediction system. Then only there will be a solution. That is the future. That is the predicted for the future. Next, please. This is a very, I read it about 2-3 days back somewhere. This is a updated statement of November 2014, few days back, I think, last month. ECMWF Director General Florence Revere, very futuristic. Because you know ECMWF is the leading organization so far as with the forecasting and climate also to some extent. Use of ML techniques to intelligently and dynamically bias correct the updated ERA A60, ERA 6. That is what I was telling in the previous also. AI can be utilized to correct the physical errors, the errors due to physical processes in the global models. Whatever dynamical bias corrections can be updated. Increasing the resolution of AIFS, that is the artificial intelligence model of IFS is the without artificial intelligence, AIFS is the artificial intelligence model, which is 100 to 28 kilometers, drastic change, 100 to 28 kilometers. Increase the use of hybrid techniques by replacing some components within the traditional NWP model with ML counterpart. That is again points to the thing I told, that you have to take a hybrid. NWP model will be there, and you take the ML counterpart and go on correcting. Novel way to generate forecasts directly from observations, circumventing the physics-based data assimilation steps. This is a little disappointing for NWP scientists who have been working so many years, because it's saying that last list or that world leading forecasts are likely to benefit from. So initially, her statement leads to that somehow there is as if there is a death of the NWP. That means you don't have to go for NWP, and only physics-based data can be used. But then he just moderated. She moderated by saying that, which I also believe will go on for. Maybe she is very futuristic, but I believe also said that in the hybrid mode. That means you have to take combination of the NWP and the AI ML modeling system. Both have to be going together. Then only there is a great future. You will get better model results, accurate data at high resolution through other modeling systems, etc. Next, please. I think this is time to summarize. I think I have 2 slides only, this and next one. Some of the thoughts. These are my contribution. All other things I cited examples. But a few slides in between was my contribution based on my understanding, and this also. Predicted climate information has big role in sustainable development goals. In time to come, there is a great hope of getting actionable climate information at high resolution using state-of-the-art climate models and data science techniques. That is both together. Application scientists can use best available climate data in agriculture, human health, disaster management, finance, ecosystem modeling, etc. Finance is coming up very big, climate change and finance. International agreements should be expedited, and I think India can take a big role. Looking at the political party, our government, strength of our government, India can take a very big role to expedite the international agreements, because without that also it is going on, but it will be much faster. We will stop all these actions before reaching 1.5 very comfortably. Climate actions should not be confined to governments alone. Private organizations have much bigger role to play in awareness generation and last mile connection. I think that is why we founded the Foundation of Climate Change, and from our side, that organization, Trustee, where we're financing the PhD students in their last phase and also giving programs in the schools, because awareness is very, very important. Next, please. There is a line of thinking that, these are what I read, I don't know, but there is a line of thinking that there should be more emphasis on geoengineering and carbon capture methods which will mitigate carbon effectively. Their argument is that if there is disagreement on today because we are trying to stop the emission. So financially countries are affected, that is why they disagree. But instead of doing that, if you encourage the geoengineering techniques and how the carbon can be captured, then everyone will be interested. Companies have already come up. So that trade will go up. So there will be no objection to these agreements. And because financially they will gain, and you go on emitting and capturing from the carbon, you can also diamond from that. So many other things are thinking going on. But I don't know when it will happen. But many people are supportive of these geoengineering techniques, which there is no base. That means today there is no policy. There will be a lot of problem. Again, geopolitical issues will come up. How you can change in your area by when these other areas will be affected weather-wise. You rain in your area and another place there will be no moisture. Similar things have not yet, there is no agreement. Governance rules are not yet set. But there is scientific thinking is like that. It can be open, and yes, there is a thought, that's okay. It is well known that this is, but second one is very interesting, which I believe is to some extent correct, that methane is a very potent, 80 times compared to carbon dioxide. We are giving all our emphasis on carbon dioxide, but methane is also culprit, although less in number, and it will be easier to mitigate methane. His logic is that you will mitigate the methane in an easier way, and there will be no disagreement on these issues. So why to emphasize on the carbon dioxide? You also put focus on methane, so that there will be, to some extent, the adverse effect of the climate change will be moderated. That again has to be tested, but this is another line of thinking. Education, especially at a tender age, plays a great role in creating innovative minds. Climate education at school level, at least in the non-formal mode, may help in getting out-of-the-box solutions. So non-formal, I mean, government is the formal way. Their schools, curriculum, they decide. We cannot do anything. Informal is that you learn from your parents, from the society, things like that, without any. Non-formal means there are some organizations who can go on creating awareness, giving training programs, like meteorological organizations, and they have a very important role. And when the students from the very childhood, in non-formal way, even if it's not there in the syllabus, they think about this problem, it will stay in their mind, and some genius may come up in the future and give out-of-the-box solution. But today, what is happening? In India, we are studying meteorology or climate science, etc., at the MSc level or higher up. In some developed countries at the graduation level. In our country at the graduation level, it just started in some NITs and IITs, etc. Otherwise, you are learning it as a physics student, meteorologist, but there's a difference. If you learn about the climate from the childhood and think about that, it is different from learning at the higher level. Finally, every citizen, in my opinion, can contribute his own way. It may be small. There are many ways, many awareness programs where you use less electricity, don't switch off the light when switch off the car at the red light, recycle, so many. So if you think of, you will find more of this. There are whole bucket list how you can really contribute. It is, I sometimes think the story that squirrel helped Lord Ram and to bridge that over the sea, that bridge to Lanka. So by taking the dust and going and so yes, whatever we can do, we should do. That is the. Let us hope for the best. And I don't think that it will be a doomsday because great scientists are there, great minds are there. Something will come out, and life is like that. Thank you. I hope you like this talk. And I'm sorry if I have, according to my watch,
Fine, sir.
5 minutes late.
Any questions?
Yeah.
From the application point of view, as you have, for thought provoking that you told actions, and one point last also you told that everybody should act actually at his level, whatever he can do for the mitigation part or reducing the, carbon footprint. My questions are actually, if we see the mitigation is one is adaptation by looking. Mitigation means suppose if we can adapt actually, like suppose somewhere the continuous drought is there, high temperature is there, they can change the crop, they can change the housing, something like that, going in a traditional way, if I understand, some housing which has a capacity, to reduce the impact of the heat. That is one. And second part is that the long-term projection. Is there any long-term projection which can, provocate that you should act like this or, dictate the action, that this is too much and action should be, any example anywhere, hotspot, where action, like Sahel or something like, where, the...
No, if I understood your question correctly,
Yeah.
mitigation is reducing the greenhouse gas emission.
That is one, but
Adaptation is
to face the challenge.
you let it go on and let other people decide how to reduce.
Mm-hmm.
You adapt to the system, especially sustainable development goals, that if there is a disaster, to take the risk management, try to enhance the, take the poor level from the lower level to the higher level, their living standard you enhance, then also it indirectly helps in the mitigation, indirectly. But now let us give emphasis on the, because mitigation is a geopolitical issue, we cannot stop countries asking for their development. Only hope is that when the renewable energies are largely used and becomes cheaper, like solar, wind, geothermal, all this, then only the fossil fuels can be avoided, so greenhouse gas emission will be reduced. Still, because carbon dioxide is a lifetime of 100 years, it will stay, even if you stop the use of coal, etc. today, it will take for next 100 years will also. So adaptation has to be expedited in a very larger way, in addition to the mitigation methods. Okay. So your next question is that what is longer way? Longer way means in the mitigation.
Yeah, dictating your methodology, how to how fast or how economical or
you see, surface processes, the surface, the most irreversible ways of changing the climate at the land surface changes, like deforestation, having more cities, urban life, etc. So land surface is changed to a large extent, which will take a very long time to recover from that. Okay, so one should focus on that the ecosystem should not be destroyed, longer time scale I'm telling, and land surface should not be changed to a large extent, in addition to emission, etc. Because in a way, this will also contribute. For example, polluted cities. Although we are emitting more, but if you have water bodies, you have greenery, you have a proper ecosystem, that will help you with reducing. So these are the longer time processes which we should focus on. Let us not destroy the ecosystem, the forest system, and don't change the land surface to a very large extent with high level of concrete buildings and other things, so that the water will go down, water conservation, for example, groundwater level should come up. These are mitigation processes in the longer time scale. Disaster management is the short time scale. Is it okay?
Yeah, I got it. Collapsing the whole
ecosystem
will damage severely.
So early warning system, disaster, etc.
Take care
is a
of
shorter time scale. But longer scale is these things, which are killing, which are more devastating and more dangerous than, okay.
Yeah, any other?
Sir, thank you very much for excellent talk. So, and then, sir, thanks to you and Foundation for Education Research in Climate Change for sponsoring 5 scholarship students in best paper presentation during Prof Met, sir. So, just I want to request you, sir, to give some glimpse of FERCC so that people will come to know about this foundation.
Yeah.
Thanks, sir.
You see, the genesis of this FERCC is the following. When I was chairman of the research committee in IIT Delhi for PhD students, I found that many students were not able to complete in 5 years because of so many reasons. 5 years to get the scholarship. After that, you don't get. There is parental pressure, you are getting old, should marry, and all these things, family problem. So they are in a fix. They have no money. That time scholarship was not that much also. So for some students, I arranged for bank, from the bank loan, some personal, etc. I thought that if in IIT this is a problem, what about the other educational institutions? And secondly, that there is no curriculum in the schools. So we took the both ends of the stick. At the lower end, climate change, and the higher level, the PhD. So it is only for climate change issue. And Professor Bhaskar Rao, I requested and he agreed. So it is a trust. It is running only from our money because we don't want to, if you want to get money from other people, you have to put energy for that. Go and request and apply. We don't want to do that. So at present, we are 6 students, PhD students from University of Science, Nandha University, from it is Central University, Rajasthan, places like that. And we are not giving a lot of money, but toward the end, 6 months to 1 year, we are giving. And mixing with along with the other organizations, Earthwatch Institute, and we're planning with Sama also, along with Sama. We're already giving some popular talks in schools, etc. We want to start some programs like essay computation and some training courses and observatories like UPRO. We had earlier the UPRO programs, if you know. There are observatories at 100 schools in Uttarakhand, some schools in Delhi, in Odisha. It was very successful for 5-10 years. And students were very happy to interact with the scientists. That is also in our agenda. So anybody, I thank IMD because suddenly I opened in the website, I found Giri, I think Dr. Giri has signed that FERCC fellowship is available, you can apply. Thank you very much for supporting that. More and more students are coming up. We'll be happy to. And one gentleman in Andhra University, after listening to Professor Bhaskar Rao, came forward. On the stage, he announced that I'm very impressed, and from next month, from my pension, I will contribute 10,000 each month by giving standing instruction to my bank. And we are getting 10,000 every month from them. And whenever necessary, I contribute, and Professor Bhaskar. It's a pleasure. Professor Bhaskar. He is very generous, and I knew that I approached him because I gave the idea because I knew that he is by heart like. I knew personally. I thought that he will definitely agree and come forward very quick. Yes, please.
You have?
Rice fields and animal houses. These are the major areas where the methane is emitted more, sir.
Which are?
Sir, methane,
Which source you told?
rice fields, sir,
Yeah.
and animal houses, sir, like cow dung and all.
Yeah.
So,
Waste also.
yes, sir,
Vegetable waste.
yes,
Vegetable waste.
vegetable waste. Sir, how can we mitigate if the paddy fields are emanating methane, sir?
Yeah, there is a variety of, you see, rice variety. Yeah, crop change can happen. You don't have to really grow all varieties of rice with a lot of water. So, a lot of water, you don't have to. And the irrigation system can also be improved so that water will not remain stagnant. Yeah, it's like a pond. If you see the paddy field, it's not really necessary. So advanced methods can be definitely, it can be reduced. People are thinking in that line. It is possible. We are just neglecting because we don't have knowledge. Farmers can also think of, they are also very intelligent. They don't want to use a lot of water. So they will find their own ways. What is the other source you told? Paddy and?
Animal dung and all.
As animal, very interesting is that people feed, na? Animal feed. Animal,
Livestock also, cow dung and all that.
that also there is thinking that they can change that more. Something they will add so that the release of methane will be less. It is possible. The food type, the feed you are giving is generating a lot of methane. But you can change their feed so that there will be less methane. You see, when you have no choice, you have to have innovative ideas. So these are coming up.
Sir, another challenging aspect is
And waste management, I will add. Waste management, they are trying to get energy. In I was listening to the presentation of one corporate sector, Nestle, I think, Nestle. They have in three villages, they are getting the methane by biodigesters, which is giving the cooking gas to the family. They are not depending on gas cylinders. So they are getting energy out of that, so there is less wastage because of the biodigesters. It is possible.
Yeah. Is there any more questions? Because
Time.
sir is also getting delayed. There is another talk, but you can have the opportunity to directly interact and have the questions. So on behalf of myself and India Meteorological Department, I express deep gratitude, sir, for your very eloquent and knowledgeable talk. And I am sure, although you are a hardcore professor and scientist, you have come down to, you can say, in a common man ability where anyone can understand your talk. So that is the capacity of a professor. Okay.
Thank you.
Yeah.
Thank you.
So you have discussed very well the impact of climate change and the climate actions, what a common man can do, what the scientists should do, what are the future, what are the evolutions which taken place in the past with respect to weather and climate sciences, and what are the challenges for the future. I am sure your talk will motivate all the young scientists, just like there are many questions now, but due to shortage of time, we are shortening the question answer session. And once again, I thank Professor S.K. Das on behalf of all of you for this excellent presentations and talk.
Thank you for inviting me.
Thank you, sir. Now we request our Director General to kindly felicitate Professor S.K. Das by presenting a shawl and memento.
Oh, wow. Thank you. Thank you. Oh, this is nice. Beautiful.